Hello, everybody. Welcome to our very first interview of the Robot in 3 Days live stream from Full Moon Robotics. Right now, I have with me Kavin. Welcome to the stream. Kavin, how are you today?
Doing good. Thanks for having me.
Nice, nice. So, why don't you tell the stream a little bit about yourself? What FRC team are you from? What are you majoring in? Just a little quick introduction.
Well, hi everyone. My name's Kavin. I'm a first-year student here at NC State, majoring in aerospace engineering and applied math. And I'm an alum of FRC 6908 and FTC 16967. And for
Nice.
Ri3D this year, I'm on the build sub-team.
Very good, very good. We are very glad to have you. So yesterday, I know it was a very long and but fun day. What'd you make of it? How did you think the brainstorming turned out yesterday?
I definitely think it was a great session. It was an interesting challenge to work with a robot we had already built and try to come up with ways we can modify it to make it even better for this season, which is something we've never had to do before in first because we've always had a blank slate to start off with. So it was definitely very cool to see everyone's ideas and figuring out how to work around the issue of starting with an old robot.
Yeah, exactly. It presents a lot of interesting challenges, especially when you're trying to work around a frame that's already there and you can't change certain things. It's almost like going into the off season, but it's the real season, you know?
Yeah, definitely.
So you've been working on CAD all morning, and you're modeling our robot. So why have we chosen to model our robot in CAD when we already have the robot in person?
Yeah, definitely. That's a good question. Well, first off, CAD stands for computer aided design. And the reason we use CAD is because it gives us a way to virtually model the robot and essentially build it without having to use real materials. And the advantage for that is we can basically kind of get an idea for how the robot's going to look, any of the dimensions and sizes we need for parts beforehand before we actually go out and make those parts using real tools. And I know we already have a robot, but since we are making these changes, such as adding a new shooter, having this robot in CAD will help us get a better sense of how big it's actually going to be, and we can work out any design issues beforehand instead of making the part first and then realizing it doesn't work.
That's great. That's great. I guess that leads to a lot of um, you don't have as many design conflicts, right? So when you go to actually put that shooter on that they're working on at the RoboDog space, hopefully we won't run into any issues of, uh-oh, it doesn't fit, right?
Yep, and that's one of the added benefits of CAD with the way we're operating. Since we're working out of two different workspaces, having CAD will kind of help us make sure that we are interfacing the parts correctly and that one design, what they're working on over at the Robodog space, doesn't mess up anything that's going on at the E garage.
Nice. That's really good. So what program are you using to model the robot, and why did you choose it?
Yep, so I'm using SolidWorks. And the main reason I'm using SolidWorks is because that's the one I'm most familiar with. I work fastest in SolidWorks, and I just like the features it has. But that it isn't necessarily a limiting factor. You can use whatever CAD software you like. Some of the popular ones that are used in FRC are SolidWorks, of course, Fusion 360, and Onshape. Those are probably the three biggest software people use.
Nice. So you've started making the CAD model of the robot, right? So where
Yeah.
do you start? There's obviously so many things that go into a robot. Where's the best place to start, and why did you choose it?
Well, I've felt that starting with the drivetrain would be the best part, especially with an FRC robot. So much of our design kind of hinges on the drive base because that's the central part of the robot. And we kind of take that philosophy of attaching subsystems to the drive base. So I went ahead and got started with the drivetrain as the first thing I CAD'd. And the reason behind that is once you have the drivetrain, it becomes a lot easier to figure out the placement of other mechanisms and subsystems you're working on because now you have that confined area you're going to work with.
That makes sense. Are you planning on, I know you're obviously going to put the mechanisms and things, the physical things, are you going to put any of the electronics on the CAD model? And is there any advantage to doing that?
Yeah. So since we're working in the limited time of 3 days, electronics might be on the back burner for me. They're sort of a wish list item. But definitely, if I was in a full season, I would not hesitate to model the electronics board because that'll give you a sense of where you're going to place all your components and how to package it all with the rest of the systems. And I know it'll help you a lot with saving messy wiring and making sure that you're actually including all the electronics that you need. And on the topic of kind of compromises I'm making given the time crunch, one thing I wanted to do was make sure that everything was modeled and as detailed as possible. But given the short amount of time we're working with, where I'm making the compromise is in order to have all the components modeled, I'm going to reduce the detail and quality of the CAD. So I may not model every single, hole that was drilled, but I'm going to do my best to make sure I can get as much information in as I can in the time we have.
Yeah, yeah. I'm sure I'm sure it's difficult given that we have two separate locations and then you're virtual as well. You're at home. You can't actually get your hands on this robot. So is how much of a challenge is that presenting, not being able to actually physically go measure the robot yourself and get what you need? How are you overcoming that?
Yeah, it's definitely a weird challenge, especially since this is my first year. I've never actually seen this robot before. I've never gotten to put my hands on it before. So, I've been in touch with the guys over at the e-garage and the RoboDog space, and every now and then I'll call in with them, and one of them will pull out a tape measure, and we'll just all the parts that I need to model, we'll sit down, figure out the dimensions of everything, and they'll send it over with pictures for me so that I have a reference to work off of and then I'll try to model it to the best of my ability based on the pictures and try to piece everything together. So it's definitely a big challenge with communication, but we're doing a good job of that.
Yeah, it's great for us to be able to have Discord and Slack and Relay and all these other great ways to communicate. So, all right, you've got the drivetrain that you've been working on. What's your next step?
Yep. So now that I'm almost done with the drivetrain, I'm probably going to work on getting the shooter and the interface, the handoff to our intake modeled because that was one thing we were talking about yesterday that we needed to figure out. So this is the aspect where I don't have something physical to model off of, and we're in the pure design phase. So by trying to get an idea of how the intake's going to look and how the handoff's going to look, hopefully I can get the guys in person better dimensions that are going to work for our robot.
So, for those new things that we're putting on the robot, are you giving them dimensions or are they giving you dimensions? Or is it going both ways?
It's kind of going both ways. So I know because of the CAD model I have, kind of the constraints we're working within. And based on that, we'll talk to each other, try to figure out how much space we want to work with. And once we get a consensus on a rough estimate of what we want, I'll be able to CAD it and generate proper dimensions for them to build off of.
Gotcha. And so, when you're modeling in CAD, does it are you paying attention? Do you have to pay attention to what the materials you're using is? Because obviously, if we're building this in person, we're going to use metal for the frame and we might use like Lexan or some kind of plexiglass in places. Is it all one material on CAD or do you kind of switch it up and model the robot to match those materials?
So that's one of those detail-oriented things I was talking about earlier. For the time being, I'm sticking to the default CAD material. But definitely as more time, if I have more time to make this more detailed, I can go in SolidWorks and adjust individually what each part is made of. And that'll give us a more accurate representation of what the robot looks like. But also, one nice powerful tool that CAD offers is you can estimate the weight of your parts and your overall robot. So if you go in and set all the materials correctly, you can get a pretty accurate estimate of how much your robot's going to weigh before you even build it. And that's a pretty nice thing to have since we're building within the weight limits of the FRC rules.
That's really interesting. Actually, had no idea that was even possible. Um, So teams that are watching this, I would highly recommend doing that. And speaking of teams, and especially teams in North Carolina, what advice would you give to teams that maybe don't have as much experience with CAD or have any experience, but want to get started? Is there like a way, should they just go out and try and model their whole robot? Or is there a way they can utilize CAD without um, doing everything all at once?
Yeah, that's definitely a good question. So, like I mentioned, CAD is such a powerful tool, so it's definitely worth learning it and building the skills with CAD. Um, One thing I would suggest in the off seasons, or while you've got time during the season, you can pick up CAD software. FRC actually has sponsors that give us CAD licenses, which is really nice. So you don't have to pay for any of it. But with that software, you can just start off simple by modeling, small things that you have around the shop, maybe like a table, and because those are kind of the simple stuff that helps you build the foundations of CAD, and you can get more and more advanced designs as you learn through that. Jumping straight into a robot, nice thing is a lot of the parts that you use on a robot you buy from, like AndyMark or Vex or Rev. And what those vendors do is they have CAD files of the parts you can buy on the website itself. So you can just look up whatever part you were going to use on the robot and download the CAD file, and you save a lot of time without having to CAD the part yourself.
Nice. That makes a lot of sense, and I'm sure that'll be really helpful. I know my team back in high school, we hardly ever used CAD. We would sometimes make small parts that we would 3D print, but our robot would literally get drawn on a whiteboard, and it would be there on the whiteboard for the whole 6 weeks, and we'd make changes to it as we were building it. So I know it, it's something that could really help. It's a more tangible than a whiteboard, if that makes sense.
Yeah. And I definitely won't discount the powers of a whiteboard because I'm sitting here with my whiteboard in front of me too to draw out the designs before I CAD them. But like you mentioned, CAD helps give that 3D perspective and kind of lets you get your hands on it a bit more. So you get a better sense of scale.
Nice. Yeah. When did you start using CAD? And I know you mentioned some techniques about how to learn it, but how did you learn it and where'd you come across it?
Yeah, so I first started CADing my first season of FRC when I was in 10th grade. And it I just started off, like I mentioned, CADing small things around the shop. So the first thing I CADed was a chair. Just a simple rectangular chair. And then as I kept going, I kept trying out some of the different tools that CAD had, different features, and just started getting more and more complex things going. And then when it came time to CAD a robot, like I mentioned, I would go online to AndyMark, pull the parts that we would buy, and kind of try to assemble a robot virtually, which is basically what I'm doing right now for Ri3D.
Nice. That's great. That's great. Is there anything else you think our audience would need to know about CAD or anything else?
Well, I guess just to wrap it all up, definitely if you have the capabilities, try to train some members in CAD. Not only is it useful for, planning out and designing your robot, but it's also a very useful skill if you're going into an engineering related field, because it's one of the introductory classes you learn in an engineering degree, because CAD plays such a role in the workplace as well.
Excellent. Well, it was wonderful talking to you. I'm glad we had the chance to do this, but I'm not going to hold you up any longer. I know you've got a lot more to do with the CAD and everything. So good luck with that. And audience, we are now going to our lunch break. We will be back right about 1 o'clock. Um, we hope you enjoyed the interview and thank you very much.